In exercise 310, the question is asking for you to determine the position of equilibrium for each acid-base reaction below. So in other words, is the equilibrium shifted to the right? Do you have more products? Or is the equilibrium shifted to the left? Do you have more reactants? And so you can figure that out by comparing the strength of the acids on each side of the reaction. And so first let's identify which ones are the acids. Pick a molecule, any molecule. Look for the thing that resembles it on the other side. Here, you have a hydrogen there. When you go to the right, no hydrogen there. So this molecule had a hydrogen, and then it didn't. That means it must have given it away. So that molecule donates an H+. In other words, it donates a proton. Donating a proton, that is the definition of being an acid, and so that is an acid. And if you can figure out one of those molecules, you can figure out all of them. If something is an acid, it's giving away an H+. What is it giving it to? The only other molecule there. So that other molecule has to be accepting an H+. That means it's a base. Remember, on the right side of the reaction, you have conjugates. So whatever these are, they are conjugates. Now if something is an acid on the left, the conjugate that resembles it will be the opposite. It will be a conjugate base. If something is a base on the left, the conjugate that resembles it on the other side will be the opposite. It will be a conjugate acid. So what we have here now are our two acids. So let's focus on those. We want to know how this acid on the left wants to push the reaction to the right. The acid on the right wants to push the reaction to the left. They're fighting against each other. Which one wins? Which direction does the reaction go in? Well, it's going in both directions, but which direction is it pushed in? So you get more of a certain species. That depends on which molecule is more acidic. So let's determine that quantitatively. Here we have ethanol, it's drinking alcohol. Drinking alcohol is right here. It has a pK of 16. And the other molecule we have is water. So water has a pKa very similar, but it's 15.7. So a little lower. So remember in that last video we talked about how the smaller the pKa, the stronger the acid. So water is actually more acidic than drinking alcohol, which means that it pushes the reaction in the way that it wants to go. It gives away its hydrogens more often. And so the equilibrium favors the reactants. That's just a fancy way of saying, that you have more of the stuff on the left side. Equilibrium pushes the reaction this way. Sure, you have both reactions happening, but the equilibrium favors the reaction that's going to the left. So you end up with more of the stuff that you have on the left. Equilibrium favors the reactants. And that would be it for that one. Now we can just follow that same procedure for the rest of these in this problem. So we just move our table down a little bit. And move our table over a little bit then. Okay. Move it to the next page. So here, we're looking at this here. So let's pick a molecule, any molecule. We need to figure out what the two acids are here. So let's just pick one. I've got that molecule. The thing that looks like it on the other side is this. You'll notice the one on the left has a hydrogen. The one on the right does not have that hydrogen on the oxygen. You go from having a hydrogen to not having a hydrogen. That means you gave the hydrogen away. The molecule donated an H+ or a proton. That donating a proton is the definition of an acid, and so that molecule is an acid. once you have an acid, you can fill the rest in really quickly. An acid is always paired with a base. The thing that resembles the acid on the other side, no, on the other side you have conjugates, right? Anything to the right of the arrow is a conjugate. The conjugate that resembles the acid is the opposite thing, it's a conjugate base. The conjugate that resembles the base is the opposite thing, it's a conjugate acid. Okay, so now we have our species, and we're interested in the acids. So let's get rid of those bases, they're just cluttering things up. So the acid on the left wants to push the reaction to the right. The acid on the right wants to give its hydrogen away, push the reaction to the left. Which one wins? It depends which one is the stronger acid. So let's compare them quantitatively using their pKa's. So we'll look for the pKa of that molecule there. And that is right here, it's 9.9. So here, pKa equals 9.9. The other acid, water, let's look for that. Water is right here. It has a pKa of 15.7. So pKa equals 15.7. Whichever has the smaller pKa is the stronger acid. So smaller pKa is the stronger acid. So this 9.9 is the stronger acid. So it gives away its hydrogen more often, and equilibrium favors the products. In other words, you make more of the stuff on the right. You make more products in this reaction. Sure, you have both the forward and the reverse reaction happening, but because the reactants have a stronger acid, the forward reaction happens more often than the reverse reaction, and so you end up with more products. Equilibrium favors the products. We can do the same thing with C. So pick them out. First thing we have to do is to identify the acids that are competing. So pick a molecule, any molecule, compare it with what resembles it on the other side of the arrow. And here, this has that hydrogen, this one doesn't. So that means this molecule on the left gave away a hydrogen. It donates an H+, or a proton. Remember, H+ and proton mean the same thing. Donating a proton, that's the definition for an acid. So that molecule there is an acid. Now, once you have identified one molecule, you can figure out the rest, because acids are always paired with a base. Right? The acid is giving away an H. Where does it give it? It gives it to the other molecule. That means the other molecule accepts an H, which makes it a base. The stuff on the right of the arrow, those are always conjugates. Whatever resembles the acid, the conjugate is the opposite thing. It's not an acid, it's a base. Whatever resembles the base, the conjugate is the opposite thing. It's a conjugate acid. All right, so now we have our species labeled. We know what the acids are. Let's zoom in on those. So those are our two acids. The HCl wants to push the reaction that way, give away its hydrogen. The HCO plus wants to push the reaction the other way, give away its hydrogen. Which one wins? Depends on which one's the stronger acid. So let's compare them by looking at their pKa's. First, HCl. HCl is right here. It has a pKa of -7. It's very low. This has a pKa of -7. HCO plus, let's look for that one. We see it right here. It's pretty low. It has a pKa of -7.1. Or I'm sorry, -1.74. pKa equals -1.74. So the acid with the more negative pKa, with the lower pKa, the pKa that's more to the left on a number line, that is the stronger acid. -7 is more negative than -1.74. And so that's going to give its hydrogen away more often. That forward reaction will happen more than the reverse. And so equilibrium would favor equilibrium makes more products. There are more products at equilibrium because the acid gives away its hydrogens. That acid gives away its hydrogens better than the other one. All right, last but not least, same procedure. Let's first identify our acids. So we'll take this molecule. We notice it has the 2 hydrogens. The thing that looks like it on the other side, so we're looking at this, and the thing that looks like it on the other side, that has only 1 hydrogen, so clearly going from 2 to 1, this gave away or donated one of its hydrogens. If you donate a hydrogen, that's the definition of an acid, and so that molecule will be an acid. Well, once you have one of them, you can figure everything else out. An acid is always paired with a base. Everything on the right side are always conjugates. Whatever looks like the acid, the conjugate is the opposite thing, it's a base. Whatever looks like the base, the opposite is the conjugate is the opposite thing, it's an acid. So now we have our species. Here we're interested in the acids, so we'll look at those. And what we're doing here is we want to know whether the equilibrium will favor the right if this acid is stronger, or the reactants if this acid is stronger. And so we'll compare these quantitatively by looking at their pKa's. So first, acetylene, CH, that triple bond, we see that here it has a pKa of 25. So the pKa is 25. And then ammonia, NH3, we see that here it has a pKa of 38. So pKa equals 38. The smaller the pKa, the stronger the acid. So this molecule, 25 is smaller than 38, so that molecule is a stronger acid. Because that molecule is a stronger acid, it gives away its H more than the other gives away its H. So you get more products produced. So equilibrium favors products. You make more products at equilibrium. You have more products at equilibrium than reactants. So this is just an application of using a pKa to compare the strength of 2 acids. The stronger acid pushes the equilibrium in the direction that the acid wants to go, giving away its H.